Hey, vsauce, Michael here. Gravity is a property of matter, anything with mass. This includes the moon, Earth, Jupiter, the sun, and even you, your body. In fact, if you kind of like somebody, have them stand 3/4 of a millimeter away from you. At that distance, cumulatively, every atom in your body and every atom in their body will draw you two together with the same gravitational force that the sun is exerting on you right now. Of course, we don't feel either of those forces because compared to the gravitational influence of the Earth, they are basically nothing. You don't need to concern yourself with the gravitational attraction between you and someone you're hugging, or your individual body and the sun 150 million kilometers away. In fact, the sun may as well not exist. What if the sun disappeared? Well, to be sure, it's not going to happen. The sun will die billions of years from now by expanding, boiling off our oceans, and swallowing the Earth whole. The sun is not going to simply disappear. Matter and energy don't vanish. Of course, matter can quantum tunnel to different locations, but on the scale of the sun, there is not enough time in the lifetime of millions and billions of universes for such a probability to even be worth discussing. But let's discuss it anyway, as a thought experiment, to determine how the Earth would get along with no sun. What will the Earth do and what can it do alone? At the exact moment that the sun disappeared, we would have no idea, because it takes light from the sun 8 minutes and 20 seconds to reach Earth. So for a little over 8 minutes after the sun disappeared, we would have no idea. Once we did, confusion and mass panic would most likely ensue. The sun's gravitational grasp on our planet would also take 8 minutes and 20 seconds to end. This is because gravity waves propagate at the speed of light. So, the very moment we saw our sun disappear, we would also lose its gravitational influence, and Earth would fly out in a straight line tangent to wherever it was in its orbit. The finite speed of light and gravity mean that as panic and fear spread across the Earth at the loss of our sun, we could still, for a while, look up into the sky and see our planetary buddies further out, continuing to operate as if nothing had happened. For instance, Jupiter would continue orbiting and reflecting light from a sun that no longer existed for about 30 minutes after Earth already knew the sun was gone. And depending on where Jupiter was in its orbit, it would take another 30 minutes to an hour for us to watch the reflected light of Jupiter snuff out. With no moonlight or sunlight, the universe itself would be our only source of visible light from space. In 2004, Abdul Ahad calculated that the Milky Way contributes about as much light as 1/300th of a full moon. So there would be enough light from space for us to see around a bit. But of course, electricity and fossil fuels would still be usable for a while, so cities and towns could continue to be lit by man-made sources, just like a typical night. Except it would be night everywhere. Photosynthesis would stop immediately, and this is huge. I had a great discussion about this video with Henry from Minute Physics and the new channel, Minute Earth. If you're not subscribed to Minute Earth, you definitely should be. In one of his episodes there, he mentions that 99.9% of the natural productivity on Earth is done by photosynthesis, which requires the sun. Without the sun, plants would no longer be able to inhale carbon dioxide and exhale life-sustaining oxygen. But don't worry. Collectively, all of us humans, all 7 billion of us, breathe in about 6 trillion kilos of oxygen every year. But our atmosphere contains a whopping quintillion kilos of oxygen. So even without photosynthesis, and including all of the other animals and insects and microorganisms that consume oxygen, it would take us thousands of years to run out. The poor plants themselves would be much worse off. Without the sun, most of them would die within days or weeks. Except for large plants, Giant trees, for instance, contain enough sugar for energy that they could technically live in the dark for years. Their problem is going to be that the Earth will get quite cold. In fact, mighty trees would freeze to death, their blood, the water and sap inside them solidifying, way before they died of starvation. Right now, with our sun, the average surface temperature on Earth, hot places and cold places in different seasons all considered, is an arguably comfortable 14 to 15 degrees Celsius. Without the sun to add energy, the Earth would radiate away heat exponentially, meaning it would go fast at first and then happen more and more slowly. By the end of the first week without the sun, the average surface temperature across Earth would be freezing, 0 Celsius, 32 degrees Fahrenheit. Now, temperatures like this happen all the time on Earth. We're used to it. Panic and fear and looters and anarchy aside, for the first few days or months, we could get by. But by the end of the first year without the sun, the average global surface temperature would be negative 73 degrees Celsius, negative 100 Fahrenheit. The best option, really, would be to move to geothermal areas like Yellowstone or Iceland. These places would be the few safe havens for human life after the sun. Nearly all life on Earth exists because of and is dependent upon extraterrestrial energy, the sun. But the Earth produces its own heat. Despite floating in the coldness of space for billions of years, down below the crust, the Earth is quite warm. 20% of this warmth came from the fact that when the Earth formed, mass crushed so tightly in the middle that the pressure liquefied rock. The other 80% of Earth's internal heat comes from the fact that deep in its core, radioactive elements decay, providing the energy needed to keep the Earth's core at 5,000 degrees Celsius. Anyone who failed to secure a position within one of these bastions of warmth, or perhaps underground in a community warmed and powered by nuclear fuel, would likely be dead within the first year of no sun. In the next 10 or 20 years, things would start to get wet with dew, but not with glorious water droplets, instead, droplets of liquid air. The air would literally become cold enough for the gases that make it up to condense, or form clouds and precipitate, first as rain, and then as it got colder and colder, eventually as snow. In Fritz Leiber's famous science fiction short story, A Pail of Air, this has already happened. The Earth was ripped away from the sun, and in order to survive, a family must go outdoors in a special suit and scoop up a pail of just the oxygen snow, bring it back in, and place it over a fire to warm and allow them to breathe. A year or so after the sun disappeared, Earth's oceans will have frozen over, ice all the way across. But ice is less dense than liquid water, which means that ice floats. And ice is a pretty decent insulator. So, for billions of years after the sun disappeared, liquid water could still exist at the bottom of our oceans, protected and insulated from space by miles of ice above it, and warmed by vents on the ocean floor that spew water out, superheated by Earth's interior. This would continue on Earth for a very, very long time, sun or no sun. Instead of becoming frozen and lifeless, extremophiles, like microbes that live around hydrothermal vents deep in the ocean, would be fine. They live deep in the ocean, far below the point where sunlight can penetrate, and they make energy not through photosynthesis, but via chemosynthesis, converting heat and methane and sulfur into the energy they need. They are then eaten by clams and tube worms. Extremophiles deposit minerals back into the vents, meaning that their food chain is complete. It's a circle. It's independent of the sun. Earthlings like them would thrive if the sun were to disappear. They would live just fine without ever knowing that the sun was gone, or honestly, without ever even knowing it existed in the first place. It's amazing to think that life, here on Earth, all alone, flying through space with no sun, would kind of be fine. Far from becoming a frozen dead rock or a boring dormant seed, the Earth would be a spaceship carrying living passengers with enough geothermal heat for billions of years of life. If the sun disappeared, spaceship Earth would fly out in a straight line, covering about 30 kilometers every single second. After just 1 billion years, it will have covered 900 quadrillion kilometers, or about 100,000 light years, a trip that could potentially take it all the way across our galaxy, near thousands of stars, and nothing's to say it couldn't fall into orbit around one, thaw out, and allow its still living extremophiles to proliferate life on Earth all over again. Maybe one day developing life intelligent enough to uncover whatever is left of our lives. Maybe they could even find this very video. In which case, hi, you're welcome for this video about your planet's history and journey. And as always, thanks for watching.